Hi students, so now we will start the Transcend material oscillation chapter module 7 JE questions. Okay, so the first question is, if the speed v of a bob in a simple pendulum is plotted against the tangential acceleration, then the correct graph will be represented by. So they want to plot a graph between acceleration and velocity for a pendulum. So if this is the direction of velocity, then this A is the acceleration in this direction. Okay, tangential acceleration, not the centripetal acceleration, which is towards the center. So basically it is a problem in which we have to plot a graph between acceleration and velocity of a body which is performing SHM. So in SHM, you know, displacement can be written as A sine omega t plus some initial phase. For simplicity, you can consider the initial phase to be 0 here, right? So you can assume at time 0, your body was at mean position. So at t0, y will be 0. You can add x or y, that is your wish. So this is your displacement. So velocity will be what? A omega cos omega t, right? Take the derivative of displacement, you will get velocity. If you take one more derivative, you will get acceleration. So minus a omega square sine omega t. In fact, these things you know from your board syllabus, right? So once you know the relation between v and a, so this is velocity in terms of time, this is acceleration in terms of time, but you want a graph between acceleration and velocity. So you need to relate these two. The common thing between them is obviously time, right? So how can you connect cos and sine? You know that cos square omega t plus sine square omega t will be equals to 1, right? So what is cos square omega t from here? So if I bring a omega downstairs, it will become v square by a omega square plus sine square omega t will be what from here, if you square it, a square acceleration square divided by a amplitude square, and this square you have to write, it will become omega power 4 equals to 1. So this is the equation between velocity and acceleration. Now this is equation of what? This is equation of ellipse, because equation of ellipse is x square by a square plus y square by b square equals to 1. Right, so if you compare this equation with this, it is very clear that the graph between velocity and acceleration will be an ellipse. If these two constants were same, both were a, let us say, then you can take LCM a square and then cross multiply, then you will get a circle. But you can see this constant here and this constant here are not same. So the graph will be ellipse. Okay. So the correct option would be option A. Fine. Let us see the next question now. Question number 2. The question number 2 says the displacement of a particle. So they have given you some function, very complicated function, and you have to find that complicated function is composed of how many simpler periodic functions, okay, sine functions. So the displacement y of a particle is given by a little complicated function. It is 4 cos square t by 2, where t represents time, sine 1000 t. Okay. So this expression they are asking can be considered to be result of superposition of how many simple harmonic motions. So how many simple harmonic, now simple harmonic motion means it's simple, right? 4 sine 100 t, right? So this is an SHM, simpler sine function, a sine omega t. So how many such functions make this complicated function? Now this is something very useful for you in later in engineering courses. If you do, you will learn something called Fourier analysis. So Fourier analysis was one of my favorite topic when I did in degree and masters. So what it says is any complicated function you can imagine, okay, it can be decomposed into simpler sine functions with different frequencies. and different amplitude. So if you combine different simpler sine functions with which has different amplitude and frequencies and add up, you can create any given variation. Okay, so this analysis was discovered by Fourier. So in that sense, these sine functions that we study are like the atoms in this case. Just like atoms make up the universe, the simpler sine functions make up all the complicated functions that you can think of. So we have to see how this can be decomposed into simpler sine functions. So for this kind of question, you have to be very good in trigonometry. Okay, so you have to try to think, is there any way you can write cos square theta or this sine? Though we can't do anything, but this cos square theta is something we can do. So we can write this 4 as 2 into 2 cos square t by 2 sine 1000 t, right? We'll do this way. This 2 cos square theta formula you can apply. So 2 cos square theta is 1 minus cos 2 theta, isn't it? So 2 cos square theta is 1 minus or 1 plus 1 plus. So 1 plus cos 2 theta is 2 cos square theta, 1 minus cos 2 theta is 2 sin square theta, right? So this will become 2 into, so 2 cos square theta here, 2 cos square t by 2 will become 1 plus cos 2 theta, which is theta here, t by 2. So this is t by 2. This will be t by 2. So 2 and 2 will cancel. So it will be cos t sine 1000 t. Then 2 into 1 into this. So 2 sine 1000 t. So this gives you the first sine function. Okay, simple harmonic motion. Plus remaining will be 2 cos t sine 1000 t. So now this brings you to another function, which is 2 cos a sin b. So here again you have to use the formula 2 sin a cos b is sin a plus b plus sin a minus b. Okay, sin a plus b plus sin a minus b. So all these trigonometric identities should be memorized. Okay. Anyways, I'm sure most of you know these formulas. If not, also you must try to remember it. So 2 sin 1000 t plus 2 sin a cos b sin, so this 2 will not be there because 2 sin a sin cos b is this formula, right? So sin a plus b, so it will be 1000 t plus t, so it will be 1001 t plus next will be sin a minus b, so 1000 minus 1, so it will be 999 t. So this way you can see that this complicated function is actually made up of 3 simple harmonic functions whose amplitudes are 2, 1, 1 and angular frequencies are 1000 radian per second, 1001 radian per second, 999 radian per second. Okay, so how many simpler SHM are, are present in this function? 3, right? So which is the right option? B. Let's now see the next question. Question number 3. So in question number 3, you should be knowing the formula between velocity of a particle in simple harmonic motion and displacement of the particle from its mean position. So while solving neat problems also, we have seen that formula B equals to omega root over a square minus x square. So V is the velocity at any instant and x is the displacement of the particle at that instant from mean position. Okay. So what the question number 3 says, okay, it says a particle executes SHM starting from its mean position at time 0. So at time 0, the particle is at mean position. That is important to note. So that means if you write trigonometric function for displacement, you have to write a sine omega t. Because at time 0, your displacement should be 0 because the particle is at mean position. So you must write sine function, not cos function. Okay, so that we know. And its velocity is root 3 b omega, where b is some constant, when it is at a distance b from mean position. So displacement is b itself from its main position, and omega is the angular frequency. They want you to find time taken by the particle to move from that B position to the extreme position on the same side. So let us have a picture, okay, in our mind. So this is the mean position, let's x equal to 0. This is somewhere x equals to B. This is your extreme, x equals to amplitude A. So from here to here, how much time it will take for the particle to go, that we have to find. So for that to find, you must know this x in terms of the amplitude. Okay. So to find that, first you can relate velocity with x using the formula v equals to omega root over a square minus x square. So v is given root 3 b omega, right? Root 3 b omega, and x is given b. So omega will cancel, square both the sides, you will get 3b square equals to a square minus b square. So this b square will come this side, 4b square equals to a square. So b will be equals to plus minus a by 2. So the particle could be here also, here also. So it doesn't matter because they are asking us to find from here to the extreme on the same side. So if you choose this solution, minus solution, then you will say the particle is here. On the same side means you have to go here to the extreme point. So whether from here to here or here to here, by symmetry you can see the time taken will be same. So now you know that this b is nothing but a by 2. So basically you have to find time taken by the particle to go from a by 2 to a. This is a very standard result if you remember. Otherwise you can use the reference circle technique, right? So at time 0, where was the particle according to the question? At mean position. So the particle is at mean position. So where will be the reference particle? Here, right? So this is your reference particle. Reference particle always moves anti-clockwise. So now, but then we are not supposed to find time taken from 0 to b, right? We are supposed to find from b to a, which is a by 2 to a. So a by 2 means the particle is here, a by 2. So this is a by 2. So reference particle will be here, here. Okay. Now, for this particle to reach here, the reference particle has to go from here to here, right? So the reference particle has to turn from this position vector to this position vector. So it has to turn by what angle? This much angle, theta, isn't it? So the particle is at B, which we found is a by 2. So it starts from here, and then it has to go to the extreme point on the same side. Okay. So our reference particle, which always moves anti-clockwise, has to turn from here to here. So this angle will be how much now? You know the adjacent side is a by 2, and this radius is nothing but the amplitude a, right? So we can use cos theta. So cos theta will be equals to adjacent is a by 2, hypotenuse is a, so half will come. That means theta is 60 degree. 60 degree means pi by 3. So once you know the angle covered, you know that the same angle I can write omega times time taken. So time taken will be pi by 3 omega. In terms of time period, if they asked, you can write omega as 2 pi by t. So which would be the right option? Option B.